This is the Lone Crater YouTube. We hope this video helps.
You begin by getting data into Matlab and shaping it for training. Load your table or data store and convert it to numeric arrays. Once done, normalize features with z-score or min-max scaling so gradients behave predictably. Next, split into training and validation sets, commonly 70/30 or 80/20, and form input X and target Y matrices with matching dimensions. Matlab expects inputs as columns for many functions. Finally, choose whether you need sequential data structures, like cell arrays for time series. Now you design the architecture and training regimen. Pick a network type, feed-forward for tabular, convolutional for images, LSTM for sequences, and assemble layers with appropriate activation functions. Then set training options. Choose Optimizer, SGDM, Atom, Initial Learning Rate, epochs, and minibatch size. These control convergence speed and stability. Start training with Train Network or Train and monitor loss and metrics on validation data. If training stalls, lower the learning rate or add dropout to reduce overfitting. To finish, evaluate performance on held-out test data and compute relevant metrics such as accuracy, RMSE, or confusion matrices. Once satisfied, save the train network with Save and consider export options like Matlab Coder for deployment. Make sure to run predictions in inference mode and measure speed and memory. If results are poor, one key troubleshooting tip: verify input and target shapes and look for data leakage. Mismatched dimensions or leaking validation examples are the most common silent failures that mislead model performance measurements.
Thanks for watching. Consider subscribing if we helped you.